Hello students, how are you doing? So today we are going to solve one tricky problem based on delta to star conversion. This problem seems to be a difficult problem, but actually it is a very easy problem if you approach it properly. But before starting this problem, I would like to tell you a few rules which you should follow while solving any kind of problem. That if you follow these rules, that will help you to reduce silly mistakes. Okay, so first rule is that read every problem twice or thrice before starting solution. Read every problem twice or thrice so that you shouldn't miss any information. Number 2 is, while solving problem, go stepwise. Never jump any step and try to mention each and every step in your solution. Number 3 is, whatever formula you are using, try to write it down in your solution next to your that specific step. Okay, so let's start. So this is our problem. Problem says find the source voltage across the 1 milliampere current source. So this is your current source and we have to find the voltage. For finding the voltage, what we are supposed to get? According to the Ohm's law, voltage is V is equal to I into R. So I is given, so we have to basically calculate R equivalent across this and this terminal. Okay, so we will start now. Step number 1, it says simplify the circuit. So before jumping to the complicated calculation, we will try to see if there is any possibility of series or series and parallel combination, so that we can simplify the circuit and then we will move for star delta or delta star conversion. So if you will observe properly, there are two branches. These two branches are in series. So we will simplify first this part of the circuit and after that we will move further. So for that we can easily see that these two branches are in series and combination of this is going to be equal to 2 plus 6 will be 8. Okay, so after doing this, we have to redraw the circuit. Now for drawing the circuit, we will at this point we will ignore current source. We will not draw it and we will consider it at final step. Okay, so after reducing that branch, it will be formed like this. Now we will name all resistances 1, 4, 4, 4. This is 4, 4, 4, and it is 8, and this is again 8 kilo ohm. Now we can easily identify that these two branches are in parallel. Now we will apply parallel formula. If you remember, R parallel is equal to, for two branches, multiplication of resistance divided by addition of resistances. So we are going to apply this formula and RP will be 8 into 8 upon 8 plus 8. So it will be 8 divided by 2, that is nothing but 4 kilo ohm. Okay, now we will again redraw the circuit. So we will remove that parallel branch. We have removed that branch. 1 4 4 4, and this combination after doing that calculation will be again 4 4 4 4. So after reducing those branches, we have finally got this circuit. Now in this circuit we can easily identify that we are having one delta, this is again one delta, and this is again one delta. Okay, so for that we can understand that there is not a series combination or not a parallel combination. We have only delta. So by converting any delta into star, we can get some part of that thing. Okay, so we will move to the next step, is convert delta into star. For that we need to understand which delta should convert into star. If we convert this delta, this will lead us to the complicated calculation. So what we are going to do, we will convert this delta and this delta into star. That will lead us for normal calculation. Okay, so we will again redraw the circuit. And if you remember, for converting delta into star, what we do first, we will draw star inside the delta. Yes, here we are having 1 kilo ohm. This is 4 4 4. And this is 4. So first we will draw star inside the delta, and we will give name R1, R2, and this is R3. So now we will write the formula for conversion from delta to star. For delta, here we are doing delta to star, so we will calculate star resistance, that is nothing but multiplication of adjacent element divided by addition of all elements. Okay, so and if you remember, I have told in the previous videos one more formula, that if you are having a delta of same values, all elements are having same values, so we can calculate direct for same values of delta elements. We can apply this formula, that is star R star will be equal to R delta divided by 3. So we can easily calculate the elements, but let's apply the basic formula, that is R1 is going to be equal to multiplication of adjacent elements. R1's adjacent elements are this 4 and this 4, and divided by all. So 4 plus 4 plus 4. So it will be 4 into 4 divided by 4 plus 4 plus 4. That will be 4 by 3 kilo ohm. And if you apply this formula, then also you will get the same value. So you can easily, if you are having same values of delta, you can easily apply this formula. You need not to do all these calculations. Okay, and as we can easily see that all values are the same, so the values of the star also will be same. That is R1 is equal to R2 is equal to R3. That is 4 by 3 kilo ohm. Now we will move for next delta. We will again redraw star inside the delta and name these elements RA, RB, RC. Now we can easily see that this is also same delta, so we need not to calculate again. We can put the same value as we'll get the same answer, that is 4 by 3 kilo ohm. Now after doing this, we need to redraw the circuit. So we will replace both delta by star. Okay, this is 1 kilo ohm, this is 4 by 3, this is 4 by 3, this is again 4 by 3, this is one delta star, and this is your lower one star. 4 by 3, 4 by 3, and it was 4. Okay, now in this circuit we can easily identify that these 3 elements are in series and these 3 elements are in series. Okay, so we will apply series combination formula. R of first branch, resistance of first branch, that is your this branch which we are considering, it will be 4 by 3 plus 4 plus 4 by 3, and it will be 20 by 3 kilo ohm. Now we will calculate for this branch. We are naming it as second branch SB, and it is 4 by 3 plus 4 by 3, so it will be 8 by 3 kilo ohm. So after doing this calculation, we will redraw the circuit and we will try to find R equivalent. After redrawing this, okay, after doing this, this was 1 kilo ohm, 4 by 3, it was 8 by 3, 20 by 3, and 4 by 3. Now in this circuit we can see that these two branches are in parallel, so we will again apply parallel formula. That was R parallel is equal to, if you remember, hopefully now you remember, RA into RB upon RA plus RB. So it will be 8 by 3 plus, sorry, it's not 8 by 3 plus, it will be multiplication 20 by 3 upon 8 by 3 plus 20 by 3, and it will give us 40 by 21. After taking LCM and all, we will get 40 by 21 kilo ohm. After doing this, we will again redraw the circuit. One 4 by 3, 40 by 21 and 4 by 3, and this is R equivalent. So R equivalent will be 1 plus 4 by 3 plus 40 by 21 plus 4 by 3, and this will be finally, after doing all calculation, 117 divided by 21, and that will be 5.57 kilo ohm. So after calculating R equivalent, we will move for the next step, that is calculate voltage. For calculating voltage, we will consider the whole circuit. We had a current source, this is your R equivalent, and if you remember, the value of current source was 1 milliampere. Now we have to calculate voltage. According to Ohm's law, it is I into R equivalent. So 1 milliampere and 5.57 kilo ohm. So we'll write for kilo 10 raised to 3, and final value will be 5.57 volt. This is going to be your final answer. So hope you have understood properly. Thank you.